All right, when dealing with absolute values, so if something is the absolute value, it has those bars around that number. If I'm talking about the absolute value, what would be the absolute value of 3? Yep, just 3. What about the absolute value of -3? Also 3. Good. So the actual definition of absolute value is the distance from 0. That also tells us that if it's the distance from 0, your absolute value always has to be a positive number. So with that positive output, because it's the distance from 0 and distance is always positive, regardless of if you have a positive 3 or a negative 3, you're always just the distance from 0 if you're looking at your number line. So here I am at 0. If I have a positive 3 or if I have a negative 3, that's still 3 units away either way that you go with that. And that's the purpose of absolute value. Cool, now let's try some on. So if these can either be positive or negative, my goal and what I'm trying to decipher here is inside this absolute value. The inside part could either be positive 12 or negative 12 because the absolute value of 12 is 12 and the absolute value of negative 12 is also 12. So the guts of the absolute value is really what we're focusing on. That means I want to know, when are my guts, the 5x minus 3, going to equal 12, and when are the guts of this going to equal negative 12? You drop the absolute value and you just set that inside both to the positive and the negative, because my goal here is to figure out the value of x that's going to make my statement true. Well, to make my statement true, it can either be positive or negative 12 on the inside of those absolute values, and that's what we're trying to figure out. Okay, let's just solve it. Add 3, so I've got 5x is now equal to 15. When you divide both sides by 5, x is equal to 3. Same deal, add 3 on the right, and I have 5x is now equal to a negative 9. Divide both by 5, and x is now equal to a negative 9/5. Now, do you have the exact same answer except both in positive and negative? No. So, pardon me, don't be lulled into that whenever you're going through these problems. You have x is equal to 3 and x is equal to a negative 9/5. You actually have to solve each one of those. Cool, let's do another one. For this super exciting problem, we have two absolute values. Never fear, we solve them the same way. So I'm going to have the 4x minus 3 is equal to a positive x plus 6. And we have 4x minus 3 is equal to a negative x plus 6. You're still setting it equal to the positive and the negative. It's just that side, that x plus 6, that's the positive and negative. Sweet, now solve. So the process is the same. Absolute value is equal to both the positive and the negative, and now it's just a matter of what positive and negative. Cool. So if I subtract x, I end up with a 3x minus 3 is equal to 6. Add 3 to both sides. So 3x is now equal to 9. When you divide both sides by 3, you get an x equals 3 as one of your answers. Good. For the other one, make sure you are distributing that negative sign first. So you have 4x minus 3 is now equal to a negative x minus 6. Now solve. So 5x minus 3 is now equal to a negative 6. Add 3 to both sides. 5x is equal to a negative 3. Divide both sides by 5, and I now get a negative 3/5. So you still have two answers, and you're always looking for those two answers when you have your absolute value. Cool. Awesome. So there's our equations. Let's take a look at inequalities next.